Hello and welcome to this section in which we will learn about structures and unions. I always say that this thing is important, this thing is important. So I'll again say structures and unions are also very important. We have seen many data types, integers, characters, arrays, pointers, but all of them are single type, homogeneous. But structures and unions are heterogeneous. They are kind of containers. They can contain other data types. These two types are compound types in C and are used to represent real life objects. For example, suppose you have a chair. How would you represent a chair? It has certain length, width, height. So maybe you can represent using floats, so many inches in height, width, and depth, or three-dimensional entities. These structures and unions can contain primitive or derived types. They can also contain compound types, like structure can contain structures, but that is for later discussion. One of the most critical aspects of structures is that you will have alignment problems, particularly in complex projects. When you have complex structures, you need to be very careful about alignment, otherwise you will end up using more memory than you should. At this point, I'll tell you what is alignment. Consider you have some variable of some type, let's say a character. Alignment says the address should be multiple of the number of bytes which will be occupied by that type. So if you have a character, you can store it anywhere. But if you have a shorthand, then it can be stored only at those memory addresses which are even. If you have an integer, then it can be stored at only those memory addresses which are divisible by 4. And if you have double, then it should be divisible by 8. We'll see where these alignment problems are there and how to fix them. There is a difference between structures and unions. The difference is that in structures, numbers do not overlap in memory, but in unions, numbers overlap in memory. I'll give you an example on this when we go to hands-on session. At certain point of time, you may not want an entire byte. You may want 1 bit or 2 bit or 3 bits. At that point of time, there is something called bit fields which are very useful and can be doable only by structures. This is particularly useful for those type of systems which have less memory, like embedded systems. For plain structures and unions, when I say plain, that means without pointers. We use dot operator to refer to numbers. But when you have pointer to structures, we use arrow operator, minus n, right angular bracket, to refer to its numbers. These are very simple concepts, but it will take some time to enter. I'll try to explain this as clearly as possible in our hands-on. Let's go to hands-on session. So this is where I have declared few structures and one union. First, let us focus on why I have declared it outside. When you declare a structure, it declares a type like an integer. It does not declare a variable. It declares a type. You want the type to be accessible anywhere. Therefore, you should declare structures outside any functions. Otherwise, if you declare this structure S inside a function, then this type will be accessible only within that function. Typically, all structures are declared in headers. Here I have declared in the C program itself. So as you see, S has two integers, I and J. S1 has I, C, J and D, four members, two integers, two characters. S2 also has two integers, two characters. Now, I have printed the size of S, S1 and S2. Now, assuming our integer is 4 bytes, how much do you think S1 and S2 will occupy? By normal computation, we say S will occupy 4 bytes, 8 bytes, 4 plus 4. S1 and S2 should occupy 10, 8 for two integers and 2 for each character. However, because of alignment problems, S1 will occupy 16 and S2 will occupy 12. The reason being the order in which these four members are declared. Suppose this is starting at memory location 0. So it will go up to 0, 1, 2, 3. And this will start at 4. Now this J cannot start at 5, 6, 7. It can only start at 4. So there will be 3 bytes in between. And then you have D. And then again 3 bytes will be reserved for the next incoming value, possibly an integer. So you will have 16 here. These 3 bytes is padding, but these 3 bytes are your alignment. If you look at S2, this will start at 0, this will be at 4 and 5. It's a character, no problem. So it can still begin at 8. And then 8 to 11, so you do not need padding here, but because of alignment 2 bytes are wasted. So let's run this program and see what is the output. So we concentrate on the first line of output, 8, 16 and 12. Best way to declare a structure is you take the smallest data type, declare it at one place, possibly at top, then text the next bigger, declare all of them together below that, and so on. This is very important to remember, otherwise you will be wasting memory in your system and you will have headaches, particularly when you do low-level programming in operating systems or device drivers. Next, I am introducing a keyword typed F. Notice that when we have said size of, we have used struct F. So all the time you will not prefer to type struct F. So in order to shorten the name, we give it a name. It's a synonym for this much as my struct. Type F gives you a synonym. You can say type def space int space integer. Now I have also declared a union which is also a type def, which I have said, my union. Now, as I said, structures declare a type, unions declare a type. So I can use this type to declare a variable. This S is of type myStruct. For assigning, you can assign using the dot operator. Now let's see what this myStruct contains. It contains an integer, a character, a pointer, and an array of floats having 10 members. It can also contain structures, but we will see that later. It can also contain strings. Structures can contain virtually anything. And this ptr is the pointer, so we assign it to I only. We take the address of I. Notice the syntax, how the address has been taken off. If you want to override the precedence in case you do not remember, then you should say like this. And I have only assigned to two members of the array F, which is a member of structure S. Notice the syntax very carefully, because it is the syntax which will give you problem in the beginning. Later on, you will be adapted to this. And then we print this. Similarly, I have declared a union. Now I will come to the point where I say the numbers in union overlap in memory. But before going to that point, let's see what are the values printed in this. So we see I is printed and ptr is printed, then a is printed and two members of the array are printed. So you see clearly on this line there is no overlap. All the elements are printed properly. Let us come to union. This union has a short integer which is of 2 bytes and a character. Now as you know, 1 byte can occupy up to 256 values. So if you subtract 256 from 321, you get 65. Now see carefully that I have assigned 321 to I, and therefore C will have a value of 65 because my system is a little Indian system. The question is, what is a little Indian system? A little Indian system is in which lower order byte is at higher address and higher order byte is at lower address. In big Indian system, the higher order byte is at higher address and lower order byte is at lower address. The Indianness of system depends on your processor architecture. All common Intel or AMD processors are little Indian. If you have ever worked on old Apple machines, power processors, then those are big Indian. Or RISC machines. HP has PA RISC machines, so those are big Indian. IBM has power servers, those are big Indian machines. But all our common machines are little Indian. So this will contain 65 because it is a little Indian machine. If it would have been a big Indian machine, it would contain 256. So if you run this program, you should have 65 in u.c. That is, you will get a character A. Let's see. Get A. Now, if I make it 322, you will get 66 in C. That is B. B. Now let's come to pointer. So I have declared another variable which is a pointer S1, and I have used the address of S for simplicity to keep the program short so that I don't have to assign again. Now See how arrow operator has been used to refer to the numbers of S1. Here I have used parentheses for clarity. First you get the number and then you take the value. First you get the pointer and then dereference that pointer. So this is the very basics of structures. Do not forget about alignment in this. You should preferably declare these characters at the top and the two integers at the bottom. Alignment is one of the most crucial problems when you try to port a program. That is, a program written for a different operating system or a different hardware, you want to recompile it on a different operating system or a different hardware by making adjustment. At that point, alignment comes into picture. Now, as I have shown union, it can be used to determine Indianness of system. There are many other uses of unions. When you have less memory and you want to store more, then unions can be used. So that's all for the basics of structures. In the next part, we will learn about array of structures. Till then, happy coding.